Alright, this video is meant to be an introduction on doing derivatives and power rule, specifically trying to get ready for like cal-based physics, but anyway, just so you know what you're doing. Let's first get into what a derivative is. And I think to do that first, let's go back and make a function, a straight line function here. So let's make us a graph there with a straight line on it. And so if I ask you to find the slope of this function, well, this is something y'all are used to doing. Finding the slope of this is no big deal. You would come back in, you would pick a point down here, get your x initial, get your y initial, get your 2y coordinates. You do the same thing up here. You'd get your x and y's up here, x final, comma, y final. And then if I ask you to find the slope of this, you would come back and say that slope is equal to rise over run, or a change in y over a change in x. And you'd come back and say something like y final minus y initial over xf minus x initial. Okay, so there's how we'd find our slope. So that's pretty easy. So what do we need calculus for? Well, especially in the world of physics, say, all your algebra-based physics comes really from what you're looking at here. So let's take a look at a different function, and you're going to have to excuse me, my drawing skills are not superbly honed. But anyway, let's take a look. Oh, I've already messed up. Let's take a look at a function that looks like this. Now, this is going to be the tricky part. It's not a terrible looking little parabola here. But now, let's take a look at this. Alright, we're already kind of changing it up a little bit here. So if we take a look at this line, and you already know the equation of that line, the equation of parabola, y equals x, come on, square, very good. Alright, so y equals x squared. So what about if I ask you to find the slope of this line? Well, now we've got kind of an issue with this one. If we start trying to find the slope of this, you're going to notice something. The slope here, the slope here, the slope, we do not have, the slope is not the same. The slope is continually changing for every single point as we move along this x-axis. This is where the calculus comes in. How can we find values for any of these slopes around here? Well, we can get into the details behind how to do it, or just kind of go through it. What happens most of the time in the class is you start out, let's say, like this. If I ask you to find the slope of that line, well, let's get our two dots, x initial and y initial. But I mean, here's the catch. Take a look at that line. This is what's known as a secant line. The secant line in this case actually crosses in two different places here. It intercepts our line in two different places. All I really want to do is this. All the difference between doing regular old algebra, what we've got up here, and doing this, up here, this run, so to say, we've got a very large delta x value up here. And what we want to do is this. In this case, we've kind of got that same situation here. We've got this delta x. What we want to do is make this delta x approach 0. In other words, we want to bring this dot up here, this point, as close to this one as we can. So what we want to do is continually bring this dot closer. And now we can sit here and see. Let's bring that dot down to here. Nope, not close enough. So let's come down to here. Nope, still not there. What we want to do is bring those dots so close to each other, we're really at the same point. And what we want to make here is what's known as a tangent line. We want to find the slope of this line, I'll call it A. We want to find the slope of this line immediately tangent to this point on this graph. That's all calculus is allowing us to do. So this is the beauty of calculus. We're not going to get into the fundamentals of deriving this, but to find this derivative, a derivative tells you this slope. It identifies. It gives you an equation that tells you the slope of this line. So to take the derivative of, let's say, y equals x squared, well, let's take a look. What is the power rule? Well, your first calculus equation here in this regard. The power rule, if you've got a function f of x is equal to xn, the power rule says all you have to do is multiply by that power, subtract 1 from it, and then you have your derivative. So what this will do is it will allow us to find a slope. So if we go back to this parabola, the equation for parabola is y is equal to x squared. So if I want to find that slope, all I've got to do is follow this. Multiply by the exponent. So this would be 2 times x, and then subtract 1 from your power. 2 minus 1 is 1, which you really don't have to write the 1, but anyway. And I'm going to write this like y prime. So I'm saying that the derivative, the first derivative of this is 2x. Or you could just rewrite it as 2x and leave the 1 off of it. That is all there is to taking a power rule derivative. That's it. Let's go ahead and take a look at some other examples here. I've got off the problem for you. Well, I want to throw one other thing at you real quick. I want to explain this whole, what about a constant? So in other words, what if you're given a constant in the problem? Well, let's take a graph of something for a second. Let's say you've got a function. Let's say you've got a function that looks like y equals 3, just like that. Well, what would be the graph of the function y equals 3? Whoa, I just about drew this off the paper. So what would be the graph of y equals 3? Well, that's just saying y equals 3, and our line is pretty much a straight line at y equals 3. And that's all it's given us. So this will be an easy question. What is the slope of this line at y equals 3? Well, the slope of that line is 0. And so anytime you take the derivative of a constant, your slope is going to be 0. And that's all we have to know. And that's exactly what we've got. We've got a slope. Say, for example, go back. This is what's cool. Go back to this derivative we took of the parabola a second ago. We know now that the derivative of x squared is 2x. So if I ask you to find the slope of this line, let's say this. Find the slope of this line at point 0. Find the slope of the line at point 0. Let's come over here. We know that the derivative is 2x. So what is your slope when x equals 0? Well, plug in value for 0, 2 times 0. Your slope would be 0. And if you look at 0, there is no slope in this picture. Now, at x equals 1, well, let's see. 2 times 1 would be 2. So, at x equals 1, you've got a slope of 2. Now, what's going to continue to happen at that slope? It should get steeper and steeper and steeper as you continue. Well, let's find out. What about at x equals 2? So, at x equals 2, you've got a slope of 4. And you can continue to see how this gets steeper and steeper. Alright, let's go back to just doing a few power rule examples and then kind of finish this up. That was really the purpose of this video anyway, to catch somebody up who was absent. I'm going to just keep shuffling papers around because I'm irritating like that. Alright, let's go on my homework here, and this is my paper. Let's go ahead and do, we've done number 1, x squared, so let's do number 2, gx. So gx equals x cubed. So what I want to do is take the first derivative, notice by this prime notation, of x cubed. Multiply by your power, 3x. Subtract 1 from your power, and that leaves you, there you go, there's your answer. And this is the thing, you don't have to stop with this first derivative. You can keep taking derivatives. If I want to take another derivative, I can come down in here and make this little symbol. And all I got to do is, once again, multiply by my power. I've got my second derivative here. 2 times 3 is 6. X. And now I want you to take a look at something. 2 minus 1 is 1. And I'm not going to write down the number 1, but there's my answer. Oh, I don't have to stop. Prime. X equals, I could take another derivative. What's the derivative of 6x? Well, let's see. Let's do this in red, because you normally wouldn't write this. But 1 times 6 is 6. And now subtract 1 from 1. Wait a second. 1 minus 1 is 0, which means the x is canceled, so we get to here and we're to 6. This is this derivative process we got. Now let's try another one. What about h of x equals x to the negative 100? Well, you can come back in here, take a derivative. H prime x equals negative 100 times x. Subtract 1 to the negative 101, which looks a little weird, so I'm going to rewrite it as negative 100 over x to the 101. I'm going to move that x to the bottom so that I can have a positive value on that. Anyway, what about this one? Fx equals the square root of x. So how do we do that question? Well, first off, do this. If you're ever doing any of these derivatives and you're given a radical like that, just change it to x to the 1/2. And now let's do our derivative. Let's multiply by 1/2, so it'll be 1/2 times x. Now subtract 1 from 1/2. Well, that's negative 1/2. And there is your derivative. Now, I don't know of many teachers that would let you turn that in for an answer, x and negative 1/2, but we could rewrite it. We could write it as 1 over 2 times x to the 1/2. We can just take that x and negative 1/2, put it down here, and then we've got a positive value for it. Alright, I'm going to actually stop this video here, and then I'll make another one where we do some more power rule examples if you want to watch it. Maybe a couple with a little more trick to it.